There may be up there some theoretical objects, fantastic gateways allowing us to travel through space and time, white holes. And to start exploring these objects on paper, we'll have to go inside stars that are already unreal in themselves. These white holes, if they exist, are certainly hiding. Like on the other side of the darkest and perhaps also the most mysterious objects we know in the universe, namely black holes. And since we've already spent a lot of time in previous episodes on what happens in these places where reality as we know it ceases to exist, today we're only going to skim over them. The only thing you need to know before letting yourself slip into these gaping holes is that, to put it roughly, with the delicacy of a sliding cast iron door. During this descent, anything that crosses a boundary called the event horizon is, for our universe, theoretically lost forever. Because near these stars, beyond a certain point, the curvature of space-time becomes so pronounced that nothing, not even light, can escape from it. From then on, one might wonder what happens to anything that crosses this boundary and plunges toward the center. And among all the possible answers to this question, there is one that tells us that each black hole could lead somewhere. That there exists something like another side, a mirror white hole, a kind of symmetrical twin, a theoretical alter ego. This scenario, which can neither be proven nor completely refuted, predicts that at the center there can be tiny passages, fleeting exit doors, bridges leading through glass holes to other regions of space-time, to white holes. But before trying to understand how black holes could be open doors leading to a kind of upside-down unknown, we need to go back for a moment to the very nature of space and time and how they can be deformed. We live in a world where time and space are intimately connected, like two distorting sides of the same reality. They form an inseparable whole, the fabric of a cosmic tapestry covering the entirety of the universe. The space-time continuum, we walk on it, we evolve within it. In this continuum, space tells matter how to move, and in return, matter tells space how to curve. Now, these gravitational wells known as black holes concentrate enough mass into a tiny volume to push the curvature of this continuum. At its very limits, this results in a sphere of absolute blackness, marking a kind of point of no return, the famous event horizon. Beyond this immaterial boundary, the movement of space-time cannot be counteracted. Everything there is, as if carried along by a conveyor belt moving under your feet too quickly. And both matter and light will inevitably end up reaching a singularity. An absurdly small region of extreme density. A distorted space-time region where continuum distortions diverge and degenerate infinitely. And yet it is here, even though our fate may seem to be sealed forever. At the level of these singularities that have carved and pierced the fabric of space-time, we might very well find gateways temporarily connecting these gaping black holes to the white. Because among all the implications that infinite curvatures of space and time can have, there are some that allow the emergence of junction tunnels between two distinct regions of space. Thus offering the opportunity to take exit doors, kinds of shortcuts that would allow extremely fast travel. There are, at the level of these singularities, mathematical solutions for two of them to be connected in hyperspace by so-called Einstein-Rosen bridges, better known as wormholes. These kinds of tunnels ensure the possible connection between black holes, the entry doors, and white holes, the exit doors. Attractive on paper and very present in science fiction, these hypothetical portals in the space-time continuum have unfortunately never been observed in reality. But since nothing prevents us from diving into them, using the only force of the known universe, which is infinite, the force of imagination, let's try to dive in now. Well, the thing is, the mathematical solutions that would allow us to use these hypothetical wormholes to travel to other parts of our universe clearly tell us you are not welcome. And you would most certainly be wiser for it. To move quickly through space, you'd be better off riding a bike on stilts than trying to go through here. Or else you'd better be extremely thin and fast. First of all, these passages have the huge drawback of being extremely small. In fact, to even hope to cross them, you'd have to be able to shrink down to the smallest scales in the universe, down to being 20 times smaller than the atomic nucleus itself. and only then could you hope to enter the 10 to the minus 33 centimeters wide entrances that we estimate these hypothetical wormholes have. Once you're facing them, avoid hesitating and jump in quickly. Because if they exist, these doors, subject to terrible quantum gravitational fluctuations, must also be extremely unstable and only open for infinitesimal periods of time, on the order of 10 to the minus 43 seconds, before violently closing in on themselves. Alternatively, if you're not extremely small and fast, you could try to enlarge and keep the wormhole open. The only catch is that, although it's theoretically possible to do this, the solution to achieve it involves using a type of exotic matter. A matter type that can exert negative pressure, reversing spatial curvature direction, and thus transform gravity into a repulsive force. The problem is that this very peculiar matter, as far as we know, has the slight drawback of not existing. In short, even if visiting these tunnels is theoretically possible, they are certainly not the most welcoming. Especially since I deliberately left out the fact that within the singularity, space-time itself is like it's boiling, constantly contracting and stretching, so to put it politely, it would gently tear you apart. And then a small detail as you approach a singularity. Theoretically, the time distortions are such that the flow of time there is almost at a standstill. So, no matter how short it is, the path to reach one of these gateways would take you a small eternity. But let's assume you have the luxury of being able to devote a tiny amount of time to this completely ridiculous endeavor. Let's imagine that a hypothetical wormhole could be kept open long enough for someone to pass through it. Where would we end up? Well, possibly on those famous white holes from which some of the trapped matter and energy would burst out, from the black hole we would have left. Unlike that of a black hole, the event horizon of a white hole is not a point of no return, but rather a passageway. A virtual boundary impossible to penetrate, marking a limit from which matter and light can only flow outward from the singularity. Because just as the time needed to escape a black hole is infinite, so is the time needed to enter a white hole. So, on paper, white holes are like black holes in reverse, opposites in which the arrow of time moves backward. Yet, strangely, even though it is impossible, in the strongest sense of the word, to enter them or to get closer than their event horizon, these hypothetical white holes are not repulsive objects. On paper, they have mass. In fact, theoretically, if too much matter comes out of it, this could even end up causing a gravitational collapse, forming a gaping black hole in place of the white one. Except that, given the size and lifespan allowed by our theories for the wormholes feeding them, if these objects eject anything, they must be closer to... Visually, a black hole likely looks no different from a white one, resembling massive brilliant fountains rather than the common perception of darkness. Still, let's remember that just because something has never been found yet, doesn't mean it doesn't exist.
Always look on the bright side
of the dark side.
For decades, black holes existed only as a theoretical possibility on paper, before finally being discovered. Ultimately, nature will always have the final say, to find out if white holes, like black holes, have the right to earn a place in the pantheon. Extremely bizarre but very real, just like black holes, or if they are and will remain mathematical artifacts, like slightly fermented fruits of our overflowing, theoretical, and unrestrained imagination. And the most troubling thing about all this is that even if the hypotheses I've presented to you end up being disproven, there's another one that speculates that black holes literally lead to other universes, or more precisely, are places where they are born. In fact, on paper, it's entirely possible to imagine that our universe was born inside a single black hole, whose resulting plan would have given us our Big Bang. Because the conditions that theoretically exist at the heart of these hypothetical white holes are strangely similar to those that existed during the very first moments of our universe. A singularity, infinite densities, an immense expansion coming from a mysterious repulsive force, a tremendous outpouring of matter and radiation. One of those events, doesn't that remind you of something? According to black hole cosmology theory, black holes could be concealing a series of big bangs beneath their horizons, and the matter falling toward the singularity would become compacted until it reached a tremendous density. before, as if bouncing from this extraordinarily compressed center outward, producing during this rebound a new Big Bang, a new universe that could also generate black holes. New universes lead to new black holes, which in turn lead to new universes, in a never-ending cycle in which it would be impossible for us to know when the story began and when it will end. To understand how it is theoretically possible to fit inside collapsing black holes other universes literally raised within them, you have to imagine that a space that appears so small can actually be an object infinitely large on the inside. Because in reality, since beyond the event horizon of black holes, the curvature of space-time tends toward infinity, it is theoretically possible to fit something inside. A new universe with all the time, all the room, and all the space to expand, evolve, and produce new black holes, digging into space-time and its cradles, in turn giving birth to new universes, new Big Bangs, and new universes. A story that makes your head spin. Thus, these objects, pushing our knowledge of the laws of nature to their very limits, not only being the most mind-blowing things we know of in the universe, could, at least in this hypothesis, allow the creation of others. And in this model, the universes capable of forming a large number of black holes would be the ones with the greatest number of descendants, which in turn could pass on some of the physical characteristics inherited from their ancestors in a branching process, similar to a kind of cosmological natural selection, applying to the ability or inability to form black holes and therefore white holes, and thus new universes. Once again, this is just a hypothesis. We have no idea if it's true. The idea that our universe originates from a white hole created by a black hole in an older universe is intriguing on paper. Goes over my grey matter with the delicacy of a bulldozer. Even if black holes like eternal purgatories lead nowhere, even if there's no Big Bang nestled in there, there's always the possibility, not to say the hope, that light might burst forth from them, that the black holes of our universe might turn white in extremely distant futures. Thus, the idea of their possible existence, like the phoenix, could well rise from its ashes in the death of the blacks. Because we believe that the latter are not eternal, and it would then be the process of their extinction that could shed light on the birth of the whites. And to see the latter light up, you would simply have to wait. Stephen Hawking showed that, over extremely long timescales, matter that has passed beyond the event horizon of a black hole may not be so trapped after all. To understand why it is theoretically possible to hope to see black holes evaporate and begin to very slightly illuminate our universe, we have to consider that on the scale of the infinitely small, when we talk about the vacuum, it is never truly empty. It is the scene of fluctuations and constantly sees pairs of particle-antiparticle appearing out of nowhere, which immediately annihilate each other right after. However, the conditions at the event horizon of a black hole can allow these pairs of particles to be separated in a time shorter than their respective lifetimes, before they annihilate each other. In fact, the insane forces generated by the intense gravitational field, combined with the strange effects of quantum tunneling, give a non-zero probability for a particle to cross an energy barrier. Impossible to cross on paper. One particle can fall into the hole, while the other, more fortunate one, takes a path moving away from it. And in doing so, it takes with it a tiny part of the black hole's energy. And it is through this strange process of evaporation that black holes could eventually transform as a sort of grand finale into white ones. However, before such a phenomenon begins, we will have to be very patient. Because the temperature of the black hole must necessarily be lower than that of the surrounding space. However, this won't occur soon, as more massive black holes are colder. Currently, the lightest ones we know of weigh as much as a few suns. And a black hole with the mass of the sun has a temperature of about 1/10,000,000th of a Kelvin. We're this close to absolute zero. The thing is, even if space may seem cold to you, it is literally bathed everywhere by a faint, tired light called the cosmic microwave background. And even though it's very weak, it still gives space a temperature of about 2-point-something, 7 degrees Celsius above absolute zero. It's freezing cold, but not quite enough. So it's too warm for black holes, even the lightest ones we know, to start evaporating. For a black hole with about the mass of the Sun to become hotter than its surroundings, it's estimated that we'll have to wait another 10 to the 64th power years. And from that point on, things could start to get explosive. Because on paper, the temperature of a black hole is inversely proportional to its mass. By starting to radiate by evaporating, these objects will lose energy and therefore mass, and they will become hotter. And so they will lose even more mass and therefore become even hotter. And so on until they are nothing but black holes, as if heated white hot. And as they keep evaporating, their temperature reaches such heights that the radiation becomes extremely intense, that it ends up counterbalancing the previously inescapable gravity of the singularity and thus allows them to escape from it. Each black hole then releases what was trapped inside, in a bursting cascade of radiation crossing their event horizon. Thus, white holes could somehow be the final phases of the life of black holes, their last breath ending in a kind of climax with a fade to white. In extremely distant futures, long after the last stars have gone out, these violent episodic flashes, originating from the darkest objects that exist, may then be the only and last sources of light in the entire universe. In any case, even if we will probably never know the whole truth, to know if black holes contain beyond the limits of our space-time glass holes leading to white, nor if they create new universes inside. For about 20 minutes, by the power of thought alone, your minds have done it. This makes me desperately want to escape this universe through a hole. This episode was packed with content. To learn more about me, check out my Insta. For more on black holes, stay right here.